Hey everyone, my name is Nandini Gupta, and in today's video, we are going deep into one of the most important yet slightly confusing concept of operating system, that is CPU scheduling algorithm. Now, if you ever wondered how does the CPU decide which process to run first? Why sometimes your keyboard lags when a big game is updating in the background? Why some processes finish faster even though they arrive later? Then this video is for you. We are going to learn two very important scheduling strategies, that is multi-level queue scheduling and multi-level feedback queue scheduling. We'll understand what they are, how they work, how they are different with real life example, diagrams, pros, cons, everything you need for college, exam and interview. Also to understand how computers behave. So grab your notes and let's dive right in. Let's begin with multi-level queue scheduling, often abbreviated as MLQ. Imagine a cinema hall. When people enter, they are categorized and sent to different sections, VIP section, premium section, balcony, and general. Everyone is watching the same movie, but their priority and treatments are different. That's exactly happens in multi-level queue scheduling. The operating system divides all the ready processes into separate queues based on their type or behavior. These queues are system or kernel processes. First, crucial internal task that keeps the operating system running. Second is interactive processes, that is short and responsive apps like typing or mouse clicking. Third, batch processes, background tasks like software updates, student. Fourth, student user app, less critical app like media player, word processor, etc. Now here's the twist. Each queue has its own scheduling algorithm. Yes, inside a queue, processes are scheduled by some algorithms like round robin, FCFS, that is first come first serve, shortest job first, etc. But the system always gives higher priority queues first access to the CPU. Example: if there's even one system process in the system queue, the CPU will not look at the lower queue, no matter how long they have been waiting. So, even if a student process is ready and waiting for 10 seconds, it won't be executed until all higher priority queues are empty. Also, the processes are permanently stuck in their assigned queues. They cannot move up or down. That's the biggest limitation. Now let's take a real life example of a university server. There are three tasks: admin tasks, faculty tasks, and student tasks. Admin task involves like maintaining records or backups, that is high priority. Faculty task involves uploading file, attendance and result, that is medium priority. Student task like downloading notes or checking timetable, that is lowest priority. Now imagine if admin is taking too much time, even if a student just wants to check notice, the CPU will keep saving the admin task until they are done. That results, student process has to wait. It may even starve if high quality processes keep coming one after another. So this system is efficient only if priority queue are balanced. But if higher ones are always busy, the lower ones suffer badly. Now let us understand the advantages and disadvantages of MLQ. Advantages involves it is very simple and have clean structure. Helps in process categorization. Good for system where task priorities are clearly defined and don't change much. The disadvantages include there is no flexibility. Processes can't switch queues even if their behavioral changes. Second, starvation is real threat for low priority queue. Third, not ideal for system where task loads keep changing. This approach is best for predictable fixed system not for modern multitasking environment like desktop or smartphones. Now here comes the hero of modern scheduling, multi-level feedback queue scheduling, abbreviated as MLFQ. This approach solves the biggest issue of MLQ, that is rigidity. In MLFQ, a process can move between queues based on how it behaves. The system is adaptive, constantly observing and adjusting priority. Here we can see how it works. Every new process is start in the highest priority. If it finishes quickly, it stays there. But if it uses too much CPU time, that is CPU bound, it gets demoted to a lower priority queue. A question arises, why? Let me give you the answer. Because short processes deserve quick services. Long process can wait. Also, if a process is stuck waiting for a long time in a lower queue, it can be promoted back up to prevent starvation. This balance of punishing CPU hogs and rewarding short or patient process makes the system extremely smart. Now here's a breakdown of its main features. First, multiple queue, each with different algorithm like round robin, FCFS, etc. Second, process moves up or down dynamically. Third, new process start at the top. Fourth, if time slice is exceed, process goes down. Fifth, if process waits too long, it goes up. MLFQ is like a school teacher moving students to front bench and if they behave well, or demoting them if they misbehave. It adapts to student behavior. Now let's get a real life example of it. Think about your personal computer. You move your mouse. It's an interactive process, right? CPU gives its top priority. You start rendering a video or running a game. Long, CPU heavy process, it gets pushed to lower queues. If some background updates is waiting too long, it gets pulled up temporarily. MLFQ keeps the system snappy and fair, responding to user instantly while still handling heavy tasks in the background. That's the specialty. Now let's discuss the advantages and disadvantages of MLFQ. Advantages include it is super flexible and dynamic, adapts in real time based on actual behavior, prevents starvation by promoting long waiting tasks, perfect for multitasking environment like desktop, laptops, phones, etc. Disadvantages include complex to implement. It is need fine tuning. How many queues, what should be the time quantum, when to promote or demote. So basically it's powerful but needs a smart configuration. Now let's discuss a quick compare of both MLQ and MLFQ. On the leftmost corner there is a features, in the mid there is multi-level queue, that is MLQ, and in the rightmost corner there is multi-level feedback queue, that is MLFQ. First, process movement. In multi-level queue it is fixed, and in multi-level feedback queue it is allowed. Flexibility in the multi-level queue is rigid, and in MLFQ it is adaptive. Starvation in the multi-level queue can happen, but it is preventive in multi-level feedback queue. Complexity is simple in MLQ and the complex in multi-level feedback queue. Ideal multi-level queue is static system and multi-level feedback queue is dynamic system. MLQ is like a strict army camp. MLFQ is a flexible school. Each has its purpose, but MLFQ is more modern and practical. Now let's wrap up this video by summarizing the final summary. Multi-level queue scheduling is good when process type don't change, system behavior is predictable, but it's rigid and cause starvation. Multi-level feedback queue scheduling is better when you want flexibility, system needs to adapt to different loads. You care about responsiveness and fairness. If you are building or studying modern operating system, MLFQ is the clear winner. Thanks a lot for watching this video. If you like this video, please like and share with your friends. See you in the next video. Bye bye.